Warm greetings. This is Kanishka. I done my assignment in the subject of microprocessor and microcontroller. Course code 60W504. And my topic is line follower robot. And the overview of my topics are problem statement, objective, hardware record, interfacing circuit, program for STM32, output, and conclusion. The problem statement for my topic is design and develop an autonomous line follower robot that can detect and follow the predefined path marked by the constructing line on a flat surface, efficiently navigating straight paths, curves, and sharp turns without deviating. The robot must use sensors to detect the line and make real-time adjustments, handling and vary lighting conditions, and surface incandescence to maintain stability and speed. The objective is to create a reliable robot that completes the path accurately within a specified time limit and demonstrating optimized movement and decision making abilities. And the objective is to build a robot and autonomously follows a definite line, integrate IR sensors to detect the line, the microcontroller to process sensor data, and motors to move the robot. To program the sensors and motors, use simple logic to read sensors data and determine the robot's position relative to the line. To gain the experience with the microcontroller programming, start with platforms like Arduino or Raspberry Pi. To build a foundational knowledge, begin with basic projects such as reading data from IR sensors or controlling motors. The hardware records are nuclear board, ultrasonic sensor HC SR04, and I use two LEDs, red LED and green LEDs. This is interfacing circuit. The nuclear board is an STM32 based microcontroller development board used for programming and controlling connected components like LEDs and sensors. The ultrasonic sensor measures the distance to an object by emitting ultrasonic sound waves and detecting a echo. It has four pins. VCC is connected to the 5-volt supply on the nuclear board, and ground connected to the ground of the nuclear board, and a trick connected to the one of the GPIO pin to the nuclear board, like used to send the trigger pulse. Echo connected to another GPIO pin to a nuclear board to receive the echo signal. And red LED is connected to one of the nuclear GPIO pin through the resistor to limit current and then to ground. This LED is likely programmed to turn on when the measurement distance falls below a certain threshold, including that an object is close. Green LED allows connected to one of the nuclear GPIO pins through the resistor that then to ground. This LED is probably programmed to turn on when the measurement distance is above a certain threshold, indicating that the area in front of the sensor is cleared. In this simulation, the microcontroller is programmed to measure the distance continuously. If the distance is below the set threshold, the red light glows. If the distance is above the threshold, the green LED lights up instead. In the program from STM32, it's like if digital read switch 1 is low and digital read switch is equal to high. And if case map for distance readings are 30, 400, 0 and 100. The ping mode, and if digital read switch 1 is low and digital switch 2 is high. Here's a program explanation for pins, trick pin and echo pins for the ultrasonic sensor, and a switch 1 and switch 2 for controlling the sensor, LED 1 and LED 2 for status indication. In setup, start serial communications and setup pins for the sensors, switches and the LEDs. Loop is if switch 1 is pressed and switch 2 is not, measures the distance with the ultrasonic sensor. Trust code and LEDs map the distance to a threshold 0 to 100 levels, and if threshold is greater than 0, turn on LED 2, otherwise it turn on LED 1. Serial output shows the distance and threshold on the monitor. The output for my line follower robot. When powered on and placed on the line, the robot should autonomously follow the line. It will move forward when both sensors detect the line and turn in the direction of the deflector line if only one sensor detects it, and stop or adjusts its direction when it lost the line to itself. If the robot lost the line, for example, due to gap or on the obstacle, it can pause and rescan the searching until it regains the line to continue following path. I like to conclude by in building the line follower robot offers insight into basic robotics, sensor integration, and control algorithms. By working with hardware and programming, one learns the fundamentals of automated navigation systems. These principles can be scaled up to more complex autonomous systems and have applications in such areas such as industrial automation, transportation. It also helps develop program solving skills as fine tuning the robot's movement and accuracy adjusting sensors and algorithms to handle real world conditions. This hands on experience lays the groundwork for understanding advanced topics like AI and machine learning in robotics. Thank you.